Okay, so today I will discuss about the conservation of livestock feed through silage making, and in next class I will discuss about the conservation of livestock feed through hay making. So there are two basic methods for conservation of livestock feed resources. When those feed resources are available in uh, larger quantity or optimum quantity. So when more amount of the resources available, then we can store it or conserve it for further use, or we can use it in lean condition, or when these green fodders are not available. So this is that two method, that is silage making and hay making, is the best suitable method for conservation of livestock feed. So first of all, we should know about what is the conservation of fodder and how we can conserve it fodder. What is the objective of conservation of fodder? Conservation of green fodder generally. So what is that? Actually, the conservation of fodder, that means preservation, and its careful maintenance. So these two terms, preservation and maintenance. So conservation means it is a preservation and careful maintenance of certain or known quantity of fodder which was unchanged during chemical reaction, which that fodder will be unchanged during chemical reaction or any physical transformation of fodder, and when it is in excess quantity, excessively available in the fodder grown area. So when it is in excess quantity, then we conserve the fodder for future need, or to feed the when that fodder is not available, or when lean condition is available for productivity. So basically it is a preservation and careful maintenance of fodder which is unchanged during the chemical reaction and physical transformation. So there are different objectives for conservation of fodder. That first objective is to preserve the feed material or roughages, green roughages, when it is available in excess quantity. Second objective is to maintain the optimum nutritional value of fodder. Whatever the nutrient present in green fodder, we should try to maintain that quantum of nutrient in preserve or conserve fodder as well. Third objective is to shift the available feed resources from present to future use. And fourth objective is to move the feed from one location to another location in easy way. So transportation is also easy. And last objective is to assist the pasture management. This is very much important and very important objective, to assist the pasture management. So by conservation of the resources, feed resources, we also propagate, or we can also manage the pasture in well manner. So these are this is a 5 objective of conservation of fodder or green fodder. So what are those methods of the conservation? That the hay making and silage making is basically two methods of conservation of the green fodder, and these two methods are mainly in practice or generally used all over the world. And these two methods are very popular for conserving the green fodder. And hay is preserved by drying of the green fodder, and in a suitable stage, while we will discuss the hay, then we discuss about the detail how hay can be preserved and what is the stage of the harvesting of hay making plants and materials. After hay, the silage is one of the most important method of conservation, and it involves natural fermentation. We should maintain the natural fermentation process of the green material. And during the fermentation, that produces lactic acid and other organic acids as well. And we can say that the silage making is just making of the pickle और अचार जो बोलते हैं, जो अचार बनाने का मेथड है उसी तरह से साइलेज भी बनाते हैं. So just making a pickle to preserve the forage, green forage. So it is also named as the pickle of the animals or pickle of green forage or animal feed. So what is silage? Silage is a when we prepare the silage, then silage is a controlled fermentation of green fodder. When we maintain the controlled fermentation, that means the anaerobic fermentation of the green fodder. We try to maintain the anaerobic condition of green fodder crop, which retain the high moisture content. And you must remember that this is the silage which contains 25 to 35% dry matter. You must remember this, what is the dry matter of the silage, and if you subtract that 100 minus that 25 to 35%, that is the moisture content of the silage. And the CP content of the silage should be 14 to 16%. So what is the advantage of the silage making? Actually, silage which is prepared from the green fodder, and the plant which having the thick stem. So selection of the plant, selection of the green fodder is very much important for the making of the silage. So plant should be thick stem, not hollow stem plant. So thick stem plant should be selected, and generally which is not very suitable for hay making. Those plants which are not suitable for hay making, and then we select those plants for silage making like sorghum, maize, Sudan grass. So these plants, these forage plants are very much suitable for silage making, and these forage plants also containing high amount of the soluble sugars. So fermentation of and production of lactic acid will be more when we preserve this plant as a silage. And beets can also be utilized for the silage making in certain amount to maintain the fodder crop for silage making. And the silage making which kills the majority of the beet seed. This is the one of the advantage. So we can use the beets which is available in the fodder crop area, or when harvesting. Some beets are also harvested during the harvesting of the fodder. So during silage making, the seed of the beet is killed, majority of the seed killed, and silage is highly palatable feed. So there is no wastage of the feed, and animals like very much when we offer the silage feed. And organic acid which is produced during the silage making, which are similar to those normally produced in the GI tract of the ruminant especially, and so the are used in the same manner as green fodder. So there is no change in the rumen fermentation parameters and rumen fermentation and rumen microorganism when we offer the silage to the animals. And this silage is very much used and widely used in all over the world for feeding to the animals. So what is the principle of silage making? We discuss one by one. So we should maintain the anaerobic condition first. This is the first principle, to maintaining the anaerobic condition. And this is a prime requirement for silage making. And by maintaining the anaerobic condition, which allow the lactic acid bacteria to grow. And when lactic acid bacteria multiply fastly, then they convert the sugar content of the fodder or green fodder to lactic acid. and that lactic acid is a strong organic acid. And production of lactic acid and the rate of lactic acid production is very much important for good quality silages. So when lactic acid produced, pH will decline. So once the pH will decline, then the degrading action of the plant enzyme and undesirable bacteria, which is present during the silage making, which will be inhibited by declining the pH. And the pH ranges should be 3 to 4 of the good quality silages. And most degrading enzymes which are inhibited and the growth of the lactic acid bacteria will also reduce. When most degrading enzymes are inhibited, then growth of the lactic acid bacteria is also inhibited at certain pH. So this is good for good quality silages. And what happens? The sugar plus oxygen is converted into, that sugar is converted into carbon dioxide, water and heat. So this reaction is prevented and the nutrient loss is reduced. So in simple word, we can say that the principle of making of silage is similar principle of making of the pickle. So we can also say that the pickle for silage is a pickle for ruminant or pickle for livestock. So what kind of the crops we should select for the making of the silage? Actually, the selection of the crop is very much important. So those crops which are having high level of the fermentable sugar, we should select for silage making. And crops should have low level of the protein. Protein content should be less, and fermentable sugar should be high. And crops should have 35% dry matter at the time of insiding. We should keep remember the dry matter content of the fodder crop or silage making. Pasture grasses we can also use for the silage making as a mixture, like elephant grass, that is a Napier grass, commonly known as Napier grass, Guinea grass, Sudan grass, and other grasses we can also use for the silage making. Pasture legumes also we can take in a small amount, not as a whole. We can mix it with the other plant material. And fodder tree like Glycinia also we can mix while preparing the silage. But it should not be a sole selection. We can mix it in certain amount. And corn and sorghum is the best crop for making of silage. And farm byproduct we can also mix it in certain quantity while preparing the silage. So selection of the site for silo pit is very much important, and site construction of the silo pit. Actually nowadays the plastic bag is available for, or plastic silage bag is available for making of the silage. So we can also prepare silage in a plastic bag, which is available in the market in different quantity, different capacity. So the silo pit, we can construct the silo pit and for permanent structure. So silo pit should be elevated from the other places. So there is no logging of the water in that area. So prevent it, water logging, and the wall of the silo pit must be leak proof. There is no chance of the leaking of the any gases or oxygen and any material, liquid material from the silage to outside from the pit. And it should be at least 6 feet away from the animal shed. So, and try to construct the silo pit in the south side of the animal shed. And silo pit size is determined by the hard side. Actually, it depends on the what is the pit size of the silo pit. What should be the size? That depends on the number of the animal. That means herd size of that particular farm area, and the daily feed intake, how much feed is required daily, and the pack density is also one of the important factor when prepare the silo feed. So we should kept in mind while constructing the silo pit. So how we can process the silage? That is, the first is harvesting of the pasture grasses, or harvesting of the pasture plant from the early heading to the heading stage. That means the flowering stage, pre-flowering to flowering stage. Pasture legumes from budding to early flowering stage. Corns, when we the maize, when we talk about the maize crop, then the corn, so yellow ripening stage. So different stages for the different plant we should take consider for making of the silage. So corn and sorghum. So corn is the ripening stage, sorghum is the milking stage. So we should cut under this condition of the plant that for making of the suitable or good quality silage. And 65 to 70% moisture, so we should take into the consideration in the green powder for ideal silage making. And if moisture level is high, then sometimes we keep that plant in open area. After cutting it, then building is required to remove the certain amount of the moisture before preparing the silage. And high moisture content, which leads to poor fermentation of that particular plant material. So silage is not of good quality when high moisture content feed we can take. And chopping of the forage to 1 to 3 centimeter length will be required for making of the silage. So we can check the packing density and lactic acid fermentation, which takes place in good condition. So chopping is essential for making of the silage. And chop fodder to make a bed of the 2 feet height in silo pit. First chop the fodder, then place the chopped fodder in a silo pit, and then compact the forage, tightly compact it with the use of the tractor or roller, handling roller, heavy roller. So we should try to remove the spaces or remove the air present between the particle of the different fodder. So the aim is to remove the air or remove the oxygen from that fodder. So we can use the tractor or hand roller for compacting the forage crop. Then we can also sprinkle some amount of the molasses solution at the rate of 2 to 3% to improve the fermentation rate, to improve the lactic acid production, and to improve the soluble sugar content in that particular silage crop, silage fodder. And if the moisture content is high, then molasses addition may not occur. So this is very much important. And so we should not use the molasses because there is no effect and wastage of the money will happen. And when moisture content of the raw material is 80% or higher, then we can use a bran. We can absorb the moisture at the rate of 10%. So wheat bran we can use, rice bran we can use at the rate of 10% when high moisture content for the reach level. In certain that is the weather, what weather we can prepare the silage, or what is the seasonal weather for preparation that will increase the moisture content of the feed or silage crop. So after that, we can seal the silage feed airtight with the plastic cover, and we should press with a heavy object like bricks, tires. We can also use soil for covering this plastic sheet. So there is no chance of any leakage of the air or any leakage of the fermentable material or liquid part from that silage pit. We should kept in mind and maintain that sealing area for 45 days at least. So during these 45 days, all the fermentation process completed, and after that we can use that silage for feeding to the animals. We can also use some additives while making of the silage, like to enhance the nutrient recovery. So we can improve the animal performance as well while using the additives, and decreasing the heating process and mold growth. Sometimes mold growth also happens in the silage additives. So we can use different additives for preparation of the silage, and direct acidifier like inorganic or organic acid which decrease the pH. So some examples, sulfuric acid and formic acid, we can use as acidifier in certain condition. Fermentation inhibitors that immediately which decrease the pH, and like formaldehyde, max grass, safe, some different names, trade names of the, and they are available. Fermentation inhibitors are available in the market. Sorbic acid salt we can also use, and that additives also provide substrate for the better fermentation. So if substrate will be provided for better fermentation of the bacteria, then more amount of the lactic acid will be produced, and it maintain the lactic acid production. So for better fermentation, we can use the molasses. Some enzymes are also used for speed up the fermentation process, like cellulase, gyalenase. So these enzymes also used. Sometimes we can use the silage inoculant. Actually, the primary purpose for adding the bacterial inoculant, which is to increase the number of the lactic acid producing bacteria. So this is very much important, silage inoculant, and in foreign country they are generally using the silage inoculant for better fermentation of the feed and conservation of the feed, and more utilization of the dry matter content. So silage inoculant we should use while preparing the silage, and some homofermentative and heterofermentative reaction takes place. So homofermentative lactic bacteria, the example of that is the Lactobacillus plantarum, Enterococcus faecium, and Pediococcus species. While heterofermentative bacteria, when less amount of the soluble sugar is present, then heterofermentative kind of the reaction takes place. So Lactobacillus buchneri. These are the inoculant which can be used for silage making. Next is that.
Sir,
Yeah.
sir, excuse me, sir. Homofermentative lactic acid bacteria
Just a
or
minute. In
heterofermentative
between, please don't ask the question in between the class, because
Okay, sir.
we are recording this lecture. It will be available for further. Okay.
Okay, sir.
So don't interfere during the class in between. You can ask question in the end of the class. So the type of fermentation, I will come to that point only what you asked, that the type of fermentation during silage formation, that is generally three types of the fermentation process takes place: homolactic or fermentation or homofermentative pathway, heterofermentative pathway, and secondary fermentation, which is not desirable for silage making, that is secondary fermentation. So homofermentative pathway, where this is very much desirable, which is required for silage formation, that is very much desirable, and common in high sugar grasses when used like maize. Maize also contain high amount of the soluble sugar. So maize is the best suitable crop for the silage making. Sugar fermentation, that sugar which is present in the fodder plant, that will be converted to lactic acid, and low pH nutrient losses may take place, and that will be mediated by the lactobacillus plantarum and lactobacillus acidilactis, and another bacteria I named that Enterococcus faecium and Pediococcus species. So these three or four type of the bacteria which perform the homofermentative pathway, and that pathway is more desirable and very much desirable for the preparation of the formation of the silage. Next is the heterofermentative pathway. This is less desirable reaction and which occurs when limited sugar are available, and that heterofermentative pathway which will be mediated by lactobacillus brevis and lactobacillus buchneri, and the sugar which mainly fermented to acetic acid, not lactic acid. You just remember this point. Sugar which mainly fermented to acetic acid and alcohols, some amount of the alcohols, and which is less efficient than homolactic fermentation. Because the silage making, the lactic acid fermentation will be the most suitable, and lactic acid producing bacteria should be in high number for better preservation of the silage crop, or for better preservation or better quality of the silage. So next is the secondary fermentation, which is very much undesirable, which is not required, but sometimes it also takes place while preparation of the silage. So this undesirable reaction, which is the degradation of the lactate by Clostridium bacteria. Sometimes Clostridium species may grow in the preparation of the preparing the silage. So this is not desirable for the silage preparation, but sometimes it happens. So there may be the chance of the infections in the animal when this kind of the bacteria grow in the silage. So that facilitated by the high moisture content. When high moisture content feed is available when preparation of the silage, so pH of that silage material will be high, and then there is the chance of the growth of the Clostridia species. Next is the fermentation process of the silage. You just go one by one. The first stage, what happens in the first stage? First stage is the respiratory stage. So in first stage, the packed raw material which are still respiring immediately after the chopping. So this is the respiratory stage, and they consume certain amount of the oxygen, and the temperature which will be rise to 32 degrees centigrade around 4 days after the packing of the food. So this is the first stage condition of the fermentation. What happens in second stage? This is the early fermentation process. So in second stage, there is the production of the acetic acid, formic acid, and different other organic acid, which results the growth of the facultative anaerobic bacteria, such as enterobacteria, and this happens in second stage, and the silage pH which slowly changes from 6 to coming less pH, that is up to the 4. What happens in third stage? Third stage is very much important, and third stage is the lactic acid fermentation stage. So in third stage, the lactic acid fermentation which begins by the lactic acid bacteria, and which are strictly anaerobic about the 3 days after packing of the chopped material. So after 3 days, lactic acid fermentation initiated, and the acetic acid production decline. Acetic acid, formic acid production declines, and lactic acid fermentation enhanced or increased. In fourth stage, Again, this lactic acid fermentation occurs in fourth stage as well, and the lactic acid production continues for 2 weeks, from third day to 2 week continue, and the temperature of the silage material goes down slowly and slowly, which is about the normal atmospheric temperature, and the pH is being maintained at 4. So pH is very much important. And in fifth stage, what happens? There is this stage is known as a stabilization stage or a stabilization phase. And due to presence of the lactic acid, that further degradation is inhibited. If further degraded or further multiplication of the lactic acid bacteria, then there is no chance of the production of the good quality silage. So fifth stage is also very much important, where is this is a stabilization stage, and the presence of lactic acid, further degradation is inhibited, and the bacterial and the fungal growth are checked at pH 4. So the lactic acid fermentation complete in about 20 days. So fermentation at a glass, we can say that if the lactic acid production is insufficient, butyric acid fermentation begins, then the quality of deterioration occurs. So fermentation process should be checked after certain period of the time. So if butyric acid fermentation begins, then the quality of the silage will deteriorate day by day. So what are the chemical changes occurs during the fermentation process? Actually, sugars which are fermented into the volatile fatty acids, lactic acid, acetic acid, propionic acid, butyric acid, under the anaerobic condition by the anaerobic microorganism, and the formation of the acid residue, and the target pH should be the 4, and the protein which is degraded into ammonia and NPN. And these are the chemical changes which occurs during the fermentation process. Here you can see that the graph, how this the lactic acid production is if lactic acid production is insufficient, then butyric acid fermentation begins. And once the butyric acid fermentation begins or starts, then the quality of the silage will be deteriorated. So we should keep in mind the lactic acid production or lactic acid fermentation is very much important for the preparation of the good quality silage. And here you can see that the chemical changes during the fermentation process, like sugar, CP, ammonia, butyric acid, acetic acid, lactic acid. So lactic acid, here you can see that the graph, lactic acid fermentation starts, and it will going and it increases in all the period up to the 41 to 50 days as well. So in that way we can maintain the good quality silage. So how we can judge the quality of the silage? Actually, color is very much important. Color, smell, taste, and touch. So these are the 4 basic judgment of the quality of silage by physical methods. So silage should be the pale yellow color, that is the good quality silage. And if the color is from dark brown to dark green, the silage underwent. Under such conditions, silage underwent bad fermentation and bad quality silage. So good quality silage is pale yellow, indicates good quality silage. A smell should be acidic or sweet sour pleasant smell, which indicates the good quality silage. Taste, if the silage tastes sour, then there is no problem, and it is a good quality. And the silage taste is bitter and some cannot put in one mouth, then the quality is poor. And the touch, actually touch should be when squeezing the silage tightly in hand, then the opening the hand, the silage breaks slowly into 2 parts, and then we can say that the silage quality is good. And the silage breaks into a small pieces separately, then silage is deficient in moisture content. And if water is dripping when squeezing it, the moisture content of the silage is too high. So this is a poor quality silage. How we can feed the silage? Actually, when 2 to 3 years old cattle, then we can feed 11 to 13 kg of the silage. When the animals in 3 to 8 years old, then we can feed 13 to 22 kg silage. In case of sheep and goat, we can feed 1 to 1.5 kg silage per 45 kg body weight. So here you can see that the size of the silo pit, and you should go through this PowerPoint and you try to understand what should be the size of the silo pit. It will depends on the types of the requirement, herd size, etc. So what kind of the nutrient losses takes place and during the silage making? Actually, there is a chance of the loss of the energy, diameter content loss, seepage loss. Some mold growth also takes place during silage making. Sometimes formic and propionic acid, which are commonly used as preservative to prevent that mold growth and bacteria. And we can increase the nutrient